how to combine our formulas for mass and molar mass with our formulas for moles and numbers of particles. So these are the two formulas that we've met so far. So the first formula connects mass to moles through the molar mass. So remember, little m is mass, little n is moles, and capital M is molar mass. Then we've got this formula which connects the number of moles, that's little n, to the number of particles, and that could be number of atoms, number of formula units, or number of molecules through Avogadro's number, Na on the bottom here. So let's try this. Here's an example. Let's say you've got 4.72 times 10 to the 23 formula units of chromium iodide, so an ionic compound. The first thing we need to do is write down our given. When you're writing down given, I would recommend starting by looking at any numbers you have in the question. So this 4.72 times 10 to the 23, what is that number? Well, it's a number of formula units, so that would mean it would be capital N, the number of particles you have, which could be number of atoms, number of formula units, or number of molecules. So we write it down as a given. Make sure that you write down its unit. Its unit is capital N. The next thing that we're given is maybe not as obvious. We're given the fact that the compound we're using is chromium 3 iodide. So that means we're given its molar mass, and you're always given that because you have a periodic table. So I've just copied a little screenshot of a periodic table here, so you can see the molar mass of chromium and the molar mass of iodine. But you have your own periodic table. This periodic table has a more accurate one than the one that I gave you, but it's similar, just slightly different. Yours is rounded off a little bit. When I write the molar mass, I always use a subscript here. So I write the symbol, right? So this is capital M is the right symbol for molar mass. We put that in. Then I write the subscript as being the chemical formula. Super handy because that tells me how many of each thing I have. And that way I can sort of do in one big step calculating the molar mass. It makes it a little bit easier. I've got 1 chromium in my chemical formula. So I put just 1 times the molar mass of chromium. But then in my chemical formula, I can see there are 3 iodines, right? So I'm going to do 3 times the molar mass of 1 iodine. And again, I pull that right off the periodic table. That gives me my molar mass of chromium iodide. So that is my given information. Of course, I always know Avogadro's number. I can write that one down too. What am I required to find? Well, once again, go back to your question. So it says we're looking for the mass. What's the symbol for mass? Lowercase m. So we're going to write little m equals question mark. That's what I'm looking for. Now we need to do some formula rearranging to connect these things. And remember, one of our key problem solving steps is that we're going to rearrange those formulas with variables first. Once all our variables are rearranged and ready to be plugged in, then we plug in at the very end. So we save the plugging in of numbers until we're all done the question, basically. Here's the two formulas we've got. We've got mass is moles times molar mass. And we know that moles is the number of particles divided by Avogadro's number. So you can see that clearly this first one is the one I want, right? I want to solve for mass, but I have a problem. I've highlighted it in red here. I don't know the number of moles, so I can't just toss things into this formula right away. What I need to do first is take this equation for the number of moles, which is number of particles over Avogadro's number, and sneak it in here for moles. So actually replace the moles in here with what it is, which is number of particles divided by Avogadro's number. So we'll write that out replaced in. So in those first brackets, instead of just being moles, I'm actually doing the number of particles divided by Avogadro's number. And it's still multiplied by the molar mass. That came from right here, right? From our mass is moles times molar mass equation. So we've literally written out the same equation as before, but I've just replaced the moles with what it is, which is number of particles over Avogadro's number. If you remember from math class, this move is called substitution. So you've definitely done this before. It's rearranged for the thing I want, right, which is mass. So I'm ready to go. I can plug all my numbers in. So you're going to want to plug in your number of particles, that's big N. Plug in Avogadro's number on the bottom. It's multiplied by the molar mass. The order does not matter with multiplication and division. So if you multiply these first and then divide, or you divide and then multiply, it doesn't matter as long as you're dividing by Avogadro's number. I would recommend putting Avogadro's number in brackets, or make sure you use your times 10 to the button on your calculator, just to make sure that you are indeed dividing by the 10 to the 23. If you don't do that, you'll get a crazy big number for mass, so you'll notice that you've made a mistake right away. If I toss that all into my calculator, the number that I get is 339 grams. Now notice I have rounded that off to 1, 2, 3 significant figures, and that's because I have 1, 2, 3 significant figures in my problem. And all I'm doing here is multiplication and division. So I'm going to use my multiplication and division significant figures rule. So that's that example. Let's try a slightly trickier one. Let's say you've got bromine gas and you have a 35.6 gram sample. We want to know how many molecules you have. So as always, we start out by writing down what are we given here. The information in the problem that's given is this 35.6 grams. That would be a mass. So we write down little m, the right symbol for mass is little m, is equal to 35.6 grams. I know it can feel a little bit annoying to write these things down every time, but it is fantastic practice and will make you a much better problem solver. So make sure you're getting the right symbol on that, little m for mass, and the right unit, grams. It becomes especially important to check this for mass because sometimes you'll get masses given to you in other units. Somebody might tell you you've got so many pounds of this or so many kilograms of this. You need to convert it to grams because grams is the standard unit in chemistry. And your equations just won't work. If you use pounds, it won't work out. We know the molar mass. That's always our other given information here. Remember that bromine is diatomic. So when you're calculating the molar mass of bromine, you're going to need to do 2 times the molar mass that you have on the periodic table of 79.904. Once again, make sure you're writing down the symbol. The symbol is capital M for molar mass, and the unit is grams per mole. Always given Avogadro's number, so I can write that one down. And what am I required to find? Let's go back to the problem again. It says how many molecules of bromine gas. So what's the symbol for numbers of molecules? Well, that would be capital N. The number of atoms, molecules, or formula units is big N. So that's what I'm looking for. My two formulas are these ones. Now here, this is tricky. Neither of these is already rearranged for capital N. Neither of them is rearranged for the number of molecules. So I'm going to have to do some work here. I'll start by taking this formula right here, and I'll rearrange it for capital N, the number of molecules. To do that is pretty straightforward. I just need to multiply both sides by Avogadro's number. If I multiply this side by Avogadro's number, it'll cancel. Well, I've got too much going on here. I'm going to do a little erasing. Here we go. So I multiply this side by Avogadro's number on the top. Multiply this by Avogadro's number as well, because whatever we do to one side, we do to the other side. And that will cancel Avogadro's number off the bottom here. So that gives me the number of particles is equal to just number of moles times Avogadro's number. Now this equation isn't rearranged for anything that I need here either. What I need to do is replace the number of moles. And the reason why I need to replace that one is because that's the only thing I don't know. So I'm going to need to take my mass equation here and rearrange for number of moles. If I divide both sides by molar mass, that should work out, right? That would cancel out my molar mass on this side and give me number of moles. So that looks like this here. I get the number of moles is equal to the mass over the molar mass. Now this is perfect. What I need to do is replace the number of moles in my capital N equation. So I'll take this equation for the number of moles and substitute it right in here for little n. So now I've got the number of molecules is equal to the number of moles, which is now just mass over molar mass. So I've replaced it, little n, with what it is, which is mass over molar mass. And then still times Avogadro's number, just like before. Now I've got one beautiful equation rearranged for the thing I want to solve for. I can plug all my numbers in and I'm good to go. So you can plug in your mass here on top, 35.6 grams, your molar mass on the bottom, 159.808 grams per mole, and Avogadro's number, 6.02 times 10 to the 23 particles. We've got 3 significant figures in our question, so we should have 3 significant figures in our answer, and we do. And so we're good to go on this question. We are all done.